I want to thank everyone for being here. I'm so honored to be here talking to you today. I know it's not easy to make the time for this event at this difficult time. My name is Cheng. Today, I'm going to talk about my time researching common flaws in ICS protocols. Everyone should know that modern hackers love to target ICS and disrupt or take control of ICS SCADA system. Many of you will already have a background knowledge about ICS and SCADA, and even have familiar with many real-world ICS threats. I will still do my best to keep this material as relatable as possible. Now, I work for TX1 Networks. TX1 is a joint venture company by Cheng and Mosa. And we focus on providing cyber defense and visibility for operational technology networks. You can see Cheng has 30 years security knowledge in high-speed DPI technology and is a world leader in threat research, while Mosa has 31 years of OT knowledge in ICS infrastructure and protocols. So we combine the cybersecurity and OT knowledge. That is TX1. Okay. And at TX1, I'm a threat researcher focused on ICS and SCADA security research. At the same time, I will also work with web application, mobile apps, IoT devices, and ICS SCADA penetration testing. I have shared my research at conferences such as ICS Cybersecurity Conference USA and Asia, Hacker in Taiwan Conference, HICOM, and Hacker in the Box Conference, HITB. And I'm also an instructor for the Ministry of Education and Ministry of National Defense in Taiwan, with courses include IoT, King Scale, and ICS security. And my partner, Selmon. Selmon is an ICS network protocol expert. He focuses on protocol processing and Linux kernel programming. And this is today's outline. I will start with ICS architecture and attack vectors, and then talk about how communication protocol works and what security risk in the ICS environment. And finally, I will share the mitigation strategy for working against ICS network protocol attacks. So first one, ICS architecture and attack vectors. This is Voodoo model, and which was developed in 1990s. This architecture was adopted by ISO 99 standard previously. And how we code it? Now we code it IEC 62443. And Voodoo model has 6 layers, numbered 0 to 5. And level 0 to level 3. Level 0 to level 3, we call it OT, or operational technology layers. And while level 4 to level 5, we call it IT. We call it IT layer. And usually in level 0, the process layer, which consists of the sensor or actuate. And in level 1, you will see the RTU, PLC, or IET kinds of controller while deploying this layer. And in level 2, you will see the local HMI, where you will see a local SCADA in area supervisory control layer. And in level 3, you will see many engineering workstation, server, instrument, we are putting it here. And totally, from level 0 to level 3, we combine the OT. And if we dive into the ICS architecture, you will find this common ICS architecture. And this slide shows the common ICS architecture. The composition of ICS contains HMI, field controller, field devices, and some of safety system, and kinds of server and engineering workstation, combine a minimal ICS environment, ICS systems. And HMI, usually we call this human machine interface, usually have 2 forms. One is touch panel, and like we see in this picture, like in here, that is touch panel based, and the other is software based, and which we usually loaded onto the Windows computer. And HMI provides a geographical representation of process for the operator, and it can be used for control, monitoring, learning, and training. And field devices are the things such as the meters for pressure, temperature, liquid flow, gas flow, and so on. And different types of factory will use different field devices. And however, in common ICS architecture, there are many attack vectors, including web attacks, different kinds of server attacks, software attacks, physical attacks on field devices, or well as attacks, including ZB, 4G, and some radio frequency. Of course, our focus today is also included ICS network protocol attacks. And before we talk about this, let me review this, like a look at how serial of ICS security, ICS threats. And this is two pictures, is advisory from ICS threat in the left side. And we will see ICS threat is a national agency owned by United States government, which focuses on the ICS security issue. And we can see that the number here, the number of the advisory is rising year by year. However, seeing this number advisory, we cannot get an evaluate of the severity because each advisory maybe have many vulnerability will be included in one advisory. So we will use the CVSS to the common vulnerability scoring system to take another look of the same data. And in the right side, we will use different vulnerability type like CWE 119. It's very high, very much number in the ICS environment, ICS cybersecurity, in property of the registration of the operation within the bound of the memory buffer. So many ICS vulnerability about this term. So also, here we use the CVSS is used to evaluate the vulnerability severity. And CVSS have two types. One is 2.0, the other is 3.0. And according to 2.0, vulnerability severity is divided into three risk levels: high, medium, and low. And 39% of vulnerabilities are ranked at high risk level. And with CVS 3.0, there are four risk level. One is critical, the other high, medium, and low. And 80% of vulnerabilities are rated as a critical risk level, and 34% of vulnerabilities are in a high risk level, which means those vulnerabilities may be easy for hackers to exploit. So it's a very serious thing. It's a very serious thing because hackers can easily to use these vulnerabilities to compromise ICS environment or systems. Okay, so here we use the ICS attack matrix to analyze past ICS incident. We can see analysis of the StarNet in 2010, Industrial in 2016, or Triton in 2017 in the ICS attack matrix website. And this way, we can use common language to explain what happened. For operator, for cybersecurity expert, for everyone, we can use a common language to explain one security incident. So for example, by comparing the StarNet here, we can see that the attacker compromised the actual workstation and use the removable media to do the initial access, to grant the initial access. Also, you can clearly see which technique, which item, which technique, monitor process data, program upload, or rootkey program download, kinds of technique used in this event. And finally, I make kinds of impact like manipulation of control, manipulation of view in here. So it's a common language provided everyone. Everyone know what happened in StarNet or what happened in the industrial, or make some impact, or how to do the impact process control in this event. It's a common language. So in this, like it's Triton, is a very famous incident. And also everyone can see this incident. And the key advantage of use ICS matrix is that everyone can clearly communication about what tactics, or procedures used by hackers. It's very easy to understand. Also, let we take a look at ICS security threat situation. And now we know ICS vulnerabilities are most operating at critical and high-risk levels, which hackers can easily exploit. And the number of the vulnerability is rising year by year, where more and more attacks are working to exploit ICS vulnerabilities. And security incidents often make a huge impact. And ICS and SCADA are not secured at all. And as the report has mentioned, 71% of sites are still using obsolete Windows systems such as Windows XP or Windows 7, while 27% of industrial sites at least one direct connection to the public internet. So for these reasons, we think ICS security, ICS is in a critical status. So we need to focus on the security issue in ICS environment. And how ICS is important, and we talk about this ICS protocols. And why we talk about this? Because the critical cybersecurity intelligence brings us today the focus points. Industrial communication protocols, the core of industrial communication. And usually in the world of industrial control, taking over the communication protocol is correlated to the mastering the entire control process. So different field will use different protocols. Like power industry usually will use DMP3 or IC1114, or in process monitoring or process control they will use Modbus, Siemens, or some of Mitsubishi or private vendors protocols. So many protocols, but protocol is very important. So usually we will see here our architecture. We already see it, but we will talk about communication protocol usually used between HMI and actual network station or field devices. So usually HMI can send a control command to PLC to controller, and controller will trigger, do the field devices, do something, process, monitor, training, and so on. And if an attacker can successfully compromise or use the ICS network protocol, they can take over the entire ICS systems. This is a very serious situation. We need to focus. So maybe you have a question. How important in ICS? Yes, so we take some country samples to look at this. In Taiwan, there are 8 critical infrastructure sectors. So at least 4 traffic, high-tech park, energy, or medical, or maybe some little communication will use ICS network to control and monitor process. So in Singapore, there are 11 CIS sectors. Also, at least 6 use ICS network protocol to control process: aviation, water, transport, healthcare, energy. And in Japan, 40 CIS sectors, at least 9 CIS sectors will use ICS network protocol. United States, 16, and at least 10. So how important of ICS network protocols? We talk about 4 countries, and most countries, they use ICS network protocol to control the critical infrastructure facilities. So if those facilities, those sectors are compromised, the impact will be huge and very serious. Maybe impact humans' life, humans' property, and we need to focus on this. So here is our introduction, and that's why we will talk about public and private ICS network protocols. Okay, now we will talk about public and private ICS network protocols. So why public and private, and what's the difference? So for public protocols, we can usually find detailed specifications on the internet. In other words, attacks can easily to become familiar with the contents of these protocols, and this is a high chance they can write exploit code, because they can very easy to research those protocols like Modbus, DMP3, or Ethernet IP specifications, and it find a way to write exploit code. And about the private protocols, on the other hand, are developed and defined by various industrial control vendors. Basically, the contents of and the specification of the protocols will not be disclosed to the public. It would mean that attacks usually have to use time-consuming reverse engineering or network protocol analysis if they want to write exploit code. So it's very time-consuming things if they want to perform kinds of attack on private protocols like Omron Things, Mitsubishi, Siemens S7. And now we will also, they are highly available. I'm sorry to say that the specification of the open protocols about the public protocol are very painful to read. For example, the simplest Modbus protocol have 51 pages. and of related reading. And Ethernet IP volume 2 has 355 pages. The MP3 has 821 pages, but Ethernet IP CIP volume 1 have more than 1,500 pages. So when you see those specifications, it is really a oh my god type situation. It's really spent. You still need to spend many time to read those documents, to understand what protocol, how to work, and try to write exploit code, and try to attack POC or HMI. And now, next we will analyze the handshake and the contents of 7 communication protocols, which including 4 public and 3 private protocols. And in this part, we will not talk about the content in too much detail because each protocol has its own features and there's not enough time. And so we talk about Modbus handshake, and HMI and POC. And Modbus is a very simple protocol, also simple, but it is used by many manufacturers. In any communication, there can be only one request and one response. So no request, no response. So for this protocol, attacker just need to know where the function call and the request data. They can try to attack function call and request data. They can try to perform kinds of attack. So as Modbus was fairly early protocols, the engineers who designed it did not consider it a security issue during its creation. No CRC, no TCP server handshake. So as you can see here, request, while it's a plain text, you will see a read holding register and just the address, word count, and about the response. You will see all of them as data and registers. So in this picture, the address and the data are not encrypted by HMI or POC. It's just plain text. It's a very serious issue. If I'm a hacker, it's already information leakage. So Ethernet IP is one. Ethernet IP CIP is relatively complicated. Here we have 3 receiver handshake set up from message 1 to message 3, and message 4 to message 5 they will register a session in Ethernet IP to register session request and response. And you will see the header and the architecture. In here is friend, an option, comment specific data, and architecture over the OSI 7 model, OSI layer 7 model. Yeah. And in the message 6 and 7, we'll use a send control message. And on the right side, CIP over Ethernet IP provided many use making CIP unable for things such as data management service or motion control. And the end of the communication, the protocol will send the unregistered request and response. So end of the entire session. So this is Ethernet IP CIP handshake process. But however, although CIP provide many and more functions than Modbus TCP, but it still was not developed with consideration of security issues. Here you can see what function and data are used, like get attribute, start, and stop. So you can see here, get attribute list. It's very easy to read, and it's already used for privacy point of view. It is already kind of information leakage. So hacker can sniff this traffic and can know what communication between the HMI and POC. It's very easy things. So this information leakage can provide attacker with a basis of full information gathering. So attacker can observe what attack methods are used in those communications and which virus can be accessed. So the subsequent attack can be successful. Here in this picture, you can see the communication of CIP connection managers, which related more complicated than Modbus, like many header, kind of network connection, original vendor, serial number, many attribute well deployed, well used in the Ethernet IP CIP traffic. So, but of course, it is necessary to know clearly the field is represent before performing attack. If we want to perform attack because as a hacker, you need to know which phone, which content, which byte, well, you can make the impact with these protocols. So you need to first know this. And also DNP3, the other public protocol and widely used in the power industry. Here we will use not use PLC. In here we use the outstation, because based on the DNP3, usually they will use the HMI or HI and the outstation communication. So this is very simple protocol. But DNP3 enhancement emphasize the time synchronization more than other protocols, because it's for power industry. They focus on time synchronizations. And the data link layer and application cross in DNP3 protocol have a CRC, but they can easy to calculate, and it in fact cannot protect the data integrate. So here you will see from message 4 to message 5 DNP3 request and response, you will see the CRC, but the CRC cannot protect the entire connection and cannot protect data integrated. So in this example, we want to read the content of the file. So here you will see our function code is read. Also, the DNP3 have many type, many content, many byte, many friends. But we need to type into if we want to perform kinds of attack. And you can see the actual response is not encrypted. So your response is plain text in this protocol for power industry. Also, the DNP3 is a very special protocol because they support the other mode, and the side for this design is for DNP3 allow the slave. In here, slave we mentioned is about, we point out the outstation, it means outstation, and slave can send a response to the HMI in some specific situations, and this does not protect the message content. So from outstation, they can do the response, emergency response to the HMI, and focus in this moment, such as design create a high risk that we can execute the spoofing for HMI, because DNP3 just will send a confirm HMI will send a confirm message to the outstation. So as a hacker, I can spoof things for HMI, send it a response, and HMI will show this message on the screen. So operator maybe will be cheated by the attack and make the wrong decisions. So also we will provide some kinds of demo later. And the last public protocols is also a protocol widely used in the power industry, electricity. And before the start of communication, the IEC 104 handshake will be conducted, and it's before TCP/3 handshake. And this start and stopped IEC handshake. And after that, we'll do the control command monitor request and response. And here you will see also many, header content in IEC 104. So they do in this header, different header, but we're not deep into this content because we don't have enough time. But in the example, we send this traffic. Here you will see start action and confirm message. Just make sure the connection channel is opened. Traffic is okay. It's okay for the HMI and RTU to communicate each other. And then IEC 104. IEC 104 provide kinds of control and monitoring requests. So also you will see in here the end message, command, and the response often are plain text passwords, so often are plain text. So of course there are no security including the design. But however, you will find one thing: they have start, action, and confirm, but they don't have stop, action, and confirm. So it's a very rare feature of IEC 104 handshake. And as present, we know that IEC 104 support many over 16 functions, a few of which are listed for reference. So as a hacker, if I want to research and I want to attack IEC 104 protocol, I will do this, research this function list and try to perform kinds of attack. And LAN overall things and private protocols. And we will talk about your private protocol like Mitsubishi, Omlong, Siemens. We will talk about this. And the things protocol will first come from the address at the beginning of the communication. So they conduct formal communication similar to Modbus. TCP string handshake, but the Modbus without this. And the things node address X and Y, and will do the real things request and the response. So also it's very similar like a Modbus part is. You just need to know the request command and data you can control with and take over the overall things protocol. So it's very easy to understanding. Just you need to create a things TCP header, things friend. You can successfully compromise the things protocols. So similar, this site have no encrypt security. So in the each traffic, each communication, you will see address sent or feedback, response, request, response. You will see all of them are the plain text password for system use, or every information are plain text. So no encryption and also no authorization and authorization. So it's very weak protocol, even they are private protocol. And that's one, and Siemens S7. And this protocol is very popular and most often studied. It is also the most complicated protocol we are looking at today. Why? Because Siemens S7 improved their own protocol many times and provided many versions. So this is basic protocol we talk about, S7. Also, serial handshake, and then the COTP connection, and message 6 to 7 will perform the step communication request and response to the step build the channel for Siemens S7 protocol. And then real Siemens S7 request and response. So here you will see, wow, S7 communication header parameter data will put in here. So before we send a real Siemens S7 packet to attack, we need to do TPKT. We need to fake a TPKT header, COTP, and S7 communication protocol header. And then in the S7, they will do the TCP four-way connection close. And then we talk about the sample. So in this sample, it's very easy to understanding because just, CR connection request and CC connection confirm, just want to make sure the channel build and for COTP and then TKT, and then set up a communication request for the COTP and S7 communication. So here already is S7 communication. So you just want to set up the communication request, then set up a response. In this moment, the channel already successfully to build, and so HMI and POC can communicate each other with the real parameter data in here. So we can send, HMI can send the Siemens S7 request here. So you will see, oh, here is plain text. So also even S7 protocol, they're very, very complicated, but they still not encrypt any information in this initial version. Okay. And then we talk about after S7 protocol, Siemens S7 Plus, hoping to improve the security of the protocol. So there has been a consideration change in the handshake process of the protocol. So in S7 Plus, there is a basic known way to obtain information related to transmission of data or on the function code used. So of course, after starting its encryption method, it can crack another attack path to identify the attack. So in on this handshake process, you will find things, all of them will be, just some TCP handshake or first time S7 connection, or will be here like connection response with object ID and value array. So in here, still not real transmission S7 Plus protocol data, but after message 7, they will do this to do the connection request with session ID and key block, and send it, get a response. And in this moment, they will do the encryption handshake actually. So they will do real S7 Plus request with integrate part. So here you will find the packet. The data will already be encrypted. So no one can retrieve the data, and send the response also you will find just encryption data will be put in here. But basically, S7 Plus has many versions, like it's version 1, version 1 in the package version, protocol version, version 2 here, integrate part in here, and version 3 is independent integrate part. So S7 has undergone several maintained improvement from version 1 to version 3. So from version 2 to version 3, the location of integrate part and the way of encryption have also changed. But however, even though S7 Plus will be doing many research by any hacker, malicious hacker, white hacker will do this research. So also, even its newest version 3, still some vulnerabilities, some security flaws in those protocols. So we still can try to attack, even it's already considered a cybersecurity issue in the protocol. So we still need to try to best to try to design a secure protocol for ICS. And here we have Misevish MailSec, a protocol. And this protocol, Wireshark cannot analyze MailSec traffic. You will see the TCP protocol in this Wireshark view. So we try to write a Lua plugin so the Wireshark can understand, and it is more convenient for us to analyze. So here, in the left side is our Lua plugin. In the right side, after our Lua plugin analyze, we can see different data, including request data, number of the world access, device number, device code, and so on, many things. So big picture, and so we can, after our analyze, we can easy to try to perform kinds of attack or analyze this, because if we want to perform attack before this, we need to get some information from Wireshark. So it's a very similar handshake to the Modbus. Also, no TCP handshake and send a request and response. So here you just need to try to request data length, timer request data, and you can try to retrieve and you can try to take over Mitsubishi MailSec protocol. So without authentication and encryption between HMI and the POC. So widely used protocol and no consider any cybersecurity issue. So we already review and simple to discuss the 7 protocol, including 4 public, 3 private protocols, and then we talk about common flaws in ICS network protocols. So here amongst of the 7 protocols we analyze, only S7 have strong landed security, and the other protocols basically have no protection against the security issues, such as authentication or message encryption. Both are designed to achieve the best availabilities and learn what kinds of specific attack and impact will disclose. So in here, we will find different protocol, public or private handshake type or authentication, message encryption, but without authentication, without encryption, the impact. What is the impact of this? So in here, we will discuss this. Here is the table, and we map some techniques in the ATT and CK matrix, which show that there will be a problem with those communication protocol, and basically the parameter of the 7 communication protocol we analyze can be modified, and they can give an authority command message. And there are a lot of ways to spoofing remote reporting message to HMI or download program from POC or to POC or upload program to POC, and the question marks, some products still have a question mark But this part is about this. It does not mean that they will not be attacked by such technique. It is just that we have not confirmed it yet. So, whether it's the public or private, those communication protocols have very high security risk. Attacker can easily perform kinds of attack with those techniques, perform denial of service, perform a modified parameter, spoof reporting message, program download uncertain common message with loss protocol. It can make a huge impact. But what kind of impact will happen in the ICS environment? So still we map to the ICS attack matrix. So there are some metrics that ICS network protocol may correspond to. So as well as the possible impacts we think in this matrix. So in this matrix, we can know the different type or the different, here in this part, inhibitor response function, process control impact, and what happened. So whatever it is to interrupt the operation of the control program, modify the perimeter, or damage physical equipment. So it's very difficult and serious things we need to focus on, because if attack use those ICS protocol perform attack, then they can make huge impact on real ICS environment. It's very, very difficult things. So we need to take. Next, I would like to demo some of our ideas about we talked a bit previously about kinds of ICS network protocol attack. And this is our TS1 ICS library. And as you can see, many ICS communication protocols are used in this lab, including Ethernet IP, Modbus TCP, Siemens S7, and other unknown protocols. And our demo will demonstrate the reference devices. So focus on Omron things, Modbus TCP, Mitsubishi MailSec. And the first demo, we will demonstrate A36 modified parameter with Mitsubishi MailSec protocol. So here we show the video demos you will see here. Okay, and then we'll take a look at this video demo and to modify the parameter. And first, in this scenario, in normal status, every 30 seconds, the light will be changed. You can see mapping of the precision between HMI and the field devices. So here, M10 and N10. So every 30 seconds will change the light. So here is automatic setting. So now every 30 seconds, the light will be changed. So just wait a second and I speed up for this video. So every 30 seconds, you will see here the light will be changed. So as a malicious hacker do in this demo, I want to modify the perimeter attack. So we will use Mitsubishi MailSec protocol to perform our attack. So wait a second, and we will show our attack view to perform kinds of attack with the modified perimeter. And here you will see our attack view. We perform attack from 30 seconds to 10 seconds. So every 10 seconds, we'll change the light, and we modify the perimeter to modify the control process. So in this scenario, our attack will from 30 seconds to 10 seconds to 2 seconds to 8 seconds and back to 30 seconds. And this attack demo is very similar, like it's probably to use a StarNet attack, because the field devices cannot after high frequency switching, it suffers physical damage and cannot use anymore. So we may simulate this demo scenario for the StarNet. So every 2 seconds it will change in this moment. So you will see every 2 seconds, just change the light. It's very quickly switching. So we'll make the field devices damage in this scenario. So we will see here. So in this demo, we use the Mitsubishi MailSec protocol to perform the modify perimeter. So here you will see in the Wireshark view, we modify the traffic from 10 seconds, 2 seconds, 8 seconds, and 30 seconds to the modify perimeter with our attack panel. This is our first demo. And second one, A43. program download with Mitsubishi MailSoft. And actually, this is a very special protocol I will never mention before. Mitsubishi MailSoft is used to the communication with engineering workstation and PLC. It's a very special protocol. And we will use this protocol to perform the program download. So also, we show the demo. So program download, and on the right side, our normal status, the program you will see is running and still running in the normal status. But as a hacker, a simulation hacker, and when I connect to this PLC, I can touch this PLC, I will do the attack and send a download command. We will download the entity program to the PLC. And when we download the program to the PLC, we'll make this PLC to enter the start operation status. So we download a PLC program, upload a PLC program to the PLC, will make an error status and make the situation will be stopped. So we successfully impact the physical process by download the program to PLC. So it's a very scenario. More advanced scenario will perform download a real and can modify the control logic process. This means we download the program to PLC, and this program can real execute in this PLC for the field devices. Maybe change the speed, maybe change the situation, or turn on or off the situation, and so on. And also is our demo, second one demo. Okay. And then we'll talk about the other demo, spoof reporting message with Modbus TCP. And now this demo will based on water environment. So let me show this demo. Okay, based on this environment, you will see the PLC, HMI, water tank, and it's a normal status. So we'll keep operation running. Or running, and value of the HMI will change. And then we perform the spoofing. And before we perform attack, we first do the up spoofing to sniff the traffic between HMI and PLC. And we want to know how to perform this attack. So we find a target of HMI and PLC. And in this scenario, we only attack HMI. We only replay the wrong message, wrong number, wrong item to the HMI. But the physical process will keep operation running normally. So we spoof the reporting message to HMI, and after we perform up spoofing, we open the Wireshark to make sure the traffic of a Modbus will go through our attacker Kali Linux. So make sure Modbus TCP traffic between already goes through our Kali Linux. And then we upload, we load a filter we pre-create this. It's focused on we modify the response to HMI, and you will find one thing is the value of HMI will already be changed, and we successfully perform the spoofing reporting message. It's successfully. So this one demo. And the last demo for our attack is authority command message with unknown things. And also it's a simple protocol. And also it's a private protocol. And let me show this demo. Send authority command message. It's a very simple scenario. In this demo, you need to focus on the motor. PLC, HMI will keep our operation running, still running in normal status. And our attack send this command from start to stopped, and for 5 seconds, and keep running. So let me show this again. Here, still running, and we send command and stopped for 5 seconds and keep running. So this is our attack scenario for send out authority command without HMI, just from attack can send command to PLC. So let's summarize this part. No authentication, no authorization, and no encryption, and a small part of stack overflow will lead to attacks. And these attacks include command injection. It's like just demand, like a impact kind of the impact will modify parameter, spoof reporting message, and also the command message, and so on. And then we will show you, finally, how to defend against the ICS network protocol attacks. It's a very important part because in ICS environment, attack is not enough. You need to know how to against those attacks, how to defend, how to detect, and how to protect. So we will talk about this. And just to recap, a vulnerable OT environment, ICS environment, and we focus on the insecure authentication and insecure protocols. So between HMI, Engineering Workstation, and this part. So it's very important things we need to focus because so many legacy devices need to a very weak list. So also we can base on network solution to protect the ICS network protocol and to do some virtual patch, to secure our environment. So according to ICS strategy, we sum up the 5 techniques to protect our ICS environment: virtual page, virtual page, perimeter defense, malware expansion, endpoint and USB lockdown, and network whitelisting. You can prevent 98% ICS incident. And about the remaining 2% is focused on the you need to build a SOC, security operation centers, for monitor and response. So next I will introduce how to implement the network whitelisting control for this talk, because today we only focus on network whitelisting and virtual page because the network base is a network base, so we focus on it here. So first one, how to perform the virtual page. You need to maybe use some devices to do virtual page and do the block some vulnerability, traffic, malicious traffic should be used to the network side to prevent the loophole or malicious traffic, like this virtual patch, like this, to deployment. Also, granular control over popular OT protocols. Of course, granular control is also necessary for the industrial control protocols themselves. We must be able to analyze kind of communication protocols and what control command and are transmit, and wherever these control commands are allowed to be used, and so on. So we strongly recommend intent-based segmentation and implement technology to give you granular control to filter, to do the network whitelisting, to protect the filter the modbus protocol, kinds of ICS network protocol and control command, to make sure something else are read-only, something can follow the SS, and something cannot do this. So it's very important things because most of ICS protocols legacy protocol, so they don't have any security they don't have a security design implement to the protocol base. So we need to do in the network base to detect our OT protocol attacks. So here we do the network whitelisting control against the Siemens S7 protocols. It's very, very important things, and we will perform a demo. But however, this demo is a simulator based. We build a Siemens S7 scenario, and we perform an attack, and we show how to do the defense, detect and defense. So here is our scenario, and without any security increment. So HMI, POC, or our sample IPS view to do the detection and protection, and attack view. So now we do the normal behavior operation between HMI and POC. You will see here the traffic, and we make sure read and write from the our simulator POC. So this normal behavior, just read and write, and just check our simulator is normally here, and just speed up a little. Here to here. So I'll make sure our normal scenario is okay. And then we set up before we perform attack, we set up our rule for network whitelisting and make sure use some module to perform attack. We want to make sure our Siemens exploit attack So perform PLC for S7. Exploit. So in this moment, we not enable any security. Without any security, we just set up target. We want to send command to the PLC. So we turn on is wrong. Here, run and stop. When we perform send command to 2 is stopped. So send it, and PLC will from run to stopped. It's successfully attacked. It's a scenario. But however, if you want to start or stop, it's very easy because basically this protocol without any security design. And then we will focus on how to prevent, how to detect this. So here is the monitor mode. So monitor mode, we just enable our network whitelisting configuration for Selmon S7 and set up this and make sure only HMI, PLC, and for the actually deny, something deny, and apply our configuration and perform attack again, some attack again, and you will find one thing is still work. Attack will still work, but however, you should have a capability to monitor the attack traffic. Because sometimes we know many ICS vendor, ICS factory, or ICS operator, they're afraid of against any traffic in the ICS environment. So, but they want to see the traffic. What happened in the ICS environment? Oh, perform attacker perform this attack. They want to run and stop ICS S7 protocol, and then we will try to perform attack again. We won't try to perform attack again, and here just quickly here to prevention mode. So we made this prevention, and we just block this prevention mode. Well, every malicious traffic will be blocked. So we can make sure our ICS environment is protected and is secure. Even the protocol is weak, is without any security, without authority, authorization, or encryption. So, but the protector will be useful for this network whitelisting. We think it's a very useful method to protect the legacy ICS network protocol, and we should do that. So here you will find the attack never already cannot successfully attack and cannot schedule real write or stop or run a PLC. So make sure this network whitelisting useful, and we can successfully protect our environment. So basically, in this demo, we showed how to protect. Initially, to just show how to protect, show how to monitor kinds of attack about ICS network protocol. So we need to protect this event because based on those protocol widely using ICS system, and lots of ICS systems are widely using CS critical infrastructure status. So we need to protect it. We need to monitor it. It's very, very important things. So I think we should keep this and make sure we can secure our ICS environment. So it is my pleasure to share with you today, and thank you for your time, and thank you for your listen. So anything, if you have question, welcome contact me. Thank you.